Hello students, we are going for a quick recap of CRTM, combined translational and rotational motion. So what we do in CRTM, we break it in two parts, translational motion plus rotational motion. And if you remember, it's the similar idea to 2D as we break in two parts, 1D plus 1D, or we break oblique collision as collision plus no collision, right? For analysis of CRTM, what we prefer? We prefer translation of center of mass plus rotation about center of mass. Rotation about center of mass, right? And also for CRTM, you have to keep in mind, if F external on the system is 0, then momentum of the system will be conserved, right? So we can write P system conserved if torque external on the system is 0, then angular momentum of the system will be conserved. So torque external on the system is 0, then angular momentum of the system will be conserved, right? Now if both are present, if both force and torque are present, then what's the idea? You have to write first, for translational motion, force equation or equations, right? For rotational motion, you have to write torque equation or equations. Then you can also get constant relation for the system. Constant relation for the रिलेशन और रिलेशंस एक या एक से ज़्यादा भी मिल सकता है फॉर द सिस्टम. Let's do a question on this concept, then it will be more understandable. Consider this question. A spool of mass m and moment of inertia about centroidal axis IC equals 3mr square over 2 is released from rest as shown in figure. Tension in the string is. We have to find out tension in string. So look, if you are going to release this from the rest, what will happen? This will go downward, right? And also it's going to rotate anti-clockwise, right? So we can say it can have a downward acceleration A, right? It can has downward acceleration A and angular acceleration clockwise alpha. So motion you see here is going to be CRTM, right? So again you have to break it into parts, translational motion plus rotational motion. For translation, what you'll do? you'll replace the body with a point object, and you can show the forces with direction tension force upward, mg downward, it's going downward, so acceleration. Now you can write the force equation, mg minus t equals ma, right? Now let's go for rotational motion. So rotational motion, rotation about center of mass. Let's see about center, this C. So how many forces acting on it? mg, torque of mg about C is 0. Torque of tension T will be TR. So we can write the torque equation about C, tau C equals IC into alpha, right? So torque about C, mg has the torque 0 and tension has TR torque. IC we have given mr square over 3 mr square over 2 and alpha. So see, we got the second equation, we can simplify this. So we will get T equals 3 mr alpha over 2. Now what? We got the second equation. You see how many variables we have? We have tension, we have acceleration, we have alpha, right? So 3 variables we have. We need one more equation, right? So we can write the constant relation. We can go for constant relation. Now look at the spool. Now look at the spool. If we are going for this point, a point on this spool here and a bottom point of this string. String is inextensible, right? So its acceleration will be 0, and here spool has acceleration a minus alpha r, right? So we can write a minus alpha r equals 0. This is the third equation, right? So we got constant relation a equals alpha r. You have to always write the constant relation. You cannot directly write a equals alpha r. Maybe here we got a equals alpha r, but in another situation you can get different values, different relation, okay? So always prefer to write the constant relation. So T equals, we can put it here, 3ma over 2. We need tension. So in first equation we can put the value of, instead of putting T, put ma. So you will directly get the value of T. So ma we have from this equation 2T over 3. Let's put this in the first equation. First equation we have mg minus T equals ma. ma we got 2T over 3. To simplify this, mg equals what? 5T over 3. So from here you got T equals 3 mg over 5, and this is our answer. We got the tension in the string, that will be 3 mg over 5. I hope you understand this question and concept behind it, and now you will be able to easily apply these concepts for the CR team questions. Thank you.